Hello, it's Brian from Matlab.net. Again, showing you something called Principal Component Analysis, PCA. Earlier today I posted a pile of links that I thought would be useful for those that may be interested in the world of application of finance with Matlab code examples for this PCA. Sadly, I only found 2 that work, and out of those, only just a real example of a Matlab function. So it really comes down to one function that works. So all these other ones are either too mathy. I mean, if you want to learn about math, go for it. Or the examples just don't work, not compatible. I don't know. I don't have the time to go through them. As opposed to some of the other examples I've shown with other mathematical forecasting types, they work fine, but PCA seems to be a bit of a problem. So let me jump into my Matlab 2013A. I'm going to show you the help that you can get with the prin comp, PRIN component function. This is the main guts of the PCA. So I'm just going to run these to show you that they do work. Let me just quit the debugging and clear everything, and let me just run it for you. So here it's running, no problem. What does it mean? Well, I'm just trying to show you that they actually work. So I'll be diving into that down the line. Let me show you another example of another one that seems to work okay. This is a framework that is developed somewhere online. This seems to work okay. Let me just pull up the help here, which is quite good actually, because it's relatively okay documented, but this thing does work. Now the cool thing about this is it's using a neural net package to do the component analysis itself. Right here, this nonlinear PCA is based on auto-associative neural network. So just so people are aware of that, I'm going to show you how it works. Again, when it comes to the actual running of it, what it means, yeah, let's leave it at that. Okay, so let me just show you some of the code examples. As I said, it seems to be in the code itself. It's fairly well documented. So you see lots of comments, but you'll see how big this is, over 2,000–3,000 lines. Now, the key is to all this just to show it running. But the interesting part, it's based off of a neural network. So let me show you what I mean. I'm going to be running each one. I'll probably have to stop the video because it will, or break it up into various segments to show you how they work. But let me just show you the first one, this demo circular. Yeah, hang on here. Helps to go into the proper directory. There we go. Okay, so we got demo circular. Okay, so I'm going to run it. Off she goes. You can see it's network training. Now, that's pretty cool. All done in Matlab. It's pretty quick, and it comes back with your result. Yeah, looks cool. You can really impress the chicks with that one. So let's go on to the next one. And remember, one of these is quite lengthy to do, so I may have to stop it. Let me just see here, or I could tell you the quant jokes, but you get the idea. It's running various set of iterations here, and something that, who knows, maybe a guy like Paul Cottrell may be interested in this framework. But you can see it's doing something, and we should all be going, ooh, ah, looks pretty cool. So that one's finished. So there's the 3 different components. Let me just blow this puppy up and see what we can come out with this. Hang on here. think you can zoom in, no? But you can manipulate it in different ways. Power of Matlab. Anyways, let's go on to the third demo. Demo inverse. I think this is the long one. Let's see what happens here. Off she goes, looking for its different PCA stuff. Now you can imagine that these little dots could be a typical time series tick date or something. Oh, it's done. There you go. This last one, missing data. Alright, this one takes a while. I always keep saying this one takes a while, but you can see it's pretty cool. It's got a little red thing going on, like a snake, and then it turns into these blue dots. So let's see what happens here. Maybe you can help me out. You can see what it's doing right now. Critical joint of optimization iteration 12. And the thing is that this code does work, which is an important thing. But you can see it comes back with a mean squared error estimating, and there you go. It's run. Cool. Hopefully this will help you out somewhere along the line. Just check out the code, the links I'll provide in the video comments or description, and all that fun stuff. At least I entertain you by having some pretty cool looking plots. Talk to you later.